In this situation, the person wants to know the mean age of a certain population. The person takes a random sample of 35 people from the population, records their 35 ages, and calculates the mean age of the 35 people. The sample mean comes out to 19. In this situation, the sampling distribution is normal because the sample size is 30 or larger. This is the sampling distribution right here. The sampling distribution tells us the probability of the sample mean coming out to a certain number. When the sampling distribution is at a low point, like right here, then the sample mean is unlikely to come out to something around that number. When the sampling distribution is at a high point, like right here, then the sample mean is likely to come out to something around that number. When the sampling distribution is normal, like it is right here, then the sample mean is likely to come out to something around the population mean, and it's unlikely to come out to a number too far to the left or too far to the right of the population mean. Since the sampling distribution is normal, I can calculate a margin of error. I calculated the 95% margin of error using the population standard deviation and the sample size. I multiplied 1.96, which comes from a table, by the standard deviation over the square root of the sample size, and I got 0.53. The 95% margin of error is 0.53. That tells us that there's a 0.95 probability of the sample mean coming out to something between 0.53 below and 0.53 above the population mean in this situation. Since we know that that's true, we can say that we're 95% confident that this sample mean of 19 is somewhere between 0.53 below and 0.53 above the population mean. We know that the sample mean had a 95% chance of falling between these 2 points. So we can say that we're 95% confident that the sample mean did actually fall between these 2 points. Now, what conclusion can we reach about this unknown population mean? Well, we said we're 95% confident that the sample mean is somewhere between these 2 boundary points. Let's try to see what the population mean would equal if the sample mean of 19 is at this boundary right here, at the upper end. If the sample mean of 19 is right here, then the population mean is 0.53 under 19. It would be 18.47. Now let's see what the population mean would equal if the sample mean of 19 was down here at this boundary. If the sample mean is down there, then the population mean would be 0.53 above 19. It would be 19.53. What we just discovered is that if the sample mean of 19 is between these 2 boundary points, then the population mean, which is unknown, can be no lower than 18.47 and no higher than 19.53. If the sample mean of 19 is between these 2 boundary points, then the unknown population mean has to be something between 18.47 and 19.53. That means that we can take this sentence here and rephrase it. We can say we're 95% confident that the population mean is somewhere between 19.47 and 19.53. And that's really saying the same thing as I'm 95% confident that the sample mean is between these 2 boundary points.